This lesson is about finding the angle measures of regular polygons. Okay, in geometry, the word regular has a very specific meaning, and you have to pay careful attention to when you're told that a polygon is a regular polygon. What it means is that all the sides of the polygon are congruent to each other. So every side is the same length, and every angle is the same measure. So you get these perfectly symmetrical looking figures with regular polygons. So as an example, an equilateral triangle with 3 congruent sides and 3 congruent angles is a regular polygon. A 4-sided quadrilateral, a square with 4 equal sides and 4 congruent angles, is a regular polygon. So let's take, for example, a regular hexagon. Now, a hexagon is a 6-sided figure, n is 6. But in a regular hexagon, all of the sides are the same length and all of the angles are the same measure. So what we want to do is take an angle, take a corner, and expand it. So we're going to redraw it bigger. And when I redraw the angle bigger, I'm going to add in the exterior angle that's adjacent to the interior angle. Now, if we want to find out the measure of one exterior angle of a regular hexagon, because that's going to help us figure out the measure of the interior angle, we start with the fact that we know that the sum of all of the exterior angles for any polygon, no matter how many sides, is always 360. So if I have 360 degrees as the sum of the exterior angles, and there are 6 sides, I know that each angle must be 360 divided by 6, or 60 degrees. So the exterior angle of a regular hexagon is 60 degrees. Now, if I want to find the measure of each interior angle, I know that an exterior angle and an interior angle are adjacent along a straight line, so they add to 180 degrees. They're supplementary. So I can find the interior angle then by just taking 180 degrees minus the exterior angle. So in this case, I've got 180 degrees minus 60, which leaves the other 120 degrees for the interior angle. So that's how you find the exterior and interior angles of a regular polygon. Okay, so let's just do a little practice. I've got number of sides, the measure of each exterior angle, and the measure of each interior angle. If I know 2 of these 3 things, if I know 1 of these 3 things, I can find the other 2. So let's start with, let's pretend we have a 10-sided figure, and now in all cases, we have to remember this only works if we've got regular polygons. Okay, so all the sides are the same, all the angles are the same. Anyway, if I have a 10-sided figure, first let's figure out what's the measure of each exterior angle. So in a 10-sided figure, it's always going to be, well, one exterior angle is always going to be 360 divided by the number of sides. So if I have 10 sides, 360 divided by 10, or 36 degrees. So each exterior angle will be 36 degrees. Then for an interior angle, it's going to be 180 minus the exterior angle. So in this case, 180 degrees minus 36 degrees, or 144 degrees. So notice that these 2 will always add up to 180 degrees. Okay, for the next exercise, let's say I'm given, I have a regular polygon, and all I know is that each exterior angle is 20 degrees. So I have to solve for the measure of the interior angle and the number of sides. So the interior angle is easy. It's the other part of the 180 degrees. So the interior angle is going to equal 160 degrees. But as to the number of sides, what we want to do is work backwards. We know that 360 divided by n equals the measure of one exterior angle. So in this case, if that exterior angle is 20 degrees, I know that 360 divided by n is 20. So then I can just solve for n. So I multiply both sides by n to get 20n is 360. So n is 18. Okay, that tells me there are 18 sides to that polygon. Okay, so for last example, let's say we have a regular polygon, and all we know, let's say we have a regular polygon, and all we know is that each interior angle has a measure of 165 degrees. So what we want to do is work it backwards, because it's always easiest to work with the exterior angles. So I know that the exterior angle has to be 180 minus 165, or 15 degrees. And now to solve for the number of sides, again, I know that 360 degrees, the sum of the measure of all the exterior angles, when I divide it by the number of sides, is equal to the measure of one exterior angle, in this case 15. So multiply both sides by n. 15n is 360 degrees. Dividing through, n equals 24 degrees. So this regular polygon would have 24 sides. And that's it.